Okay, ladies and gentlemen, here's our first video for Algebra Bootcamp. So what I've done is I put 4 topics on here, which we're going to talk about in the video, and I've given you 20 questions to go along with it. You'll watch the video first, you'll try the questions. We'll have office hours on Wednesday, so it'll be a live class, but just office hours, and this work will be due on Thursday. Some of the stuff should be pretty straightforward, some might have a little trick to it, but we're going to get through it okay. First type of problem we're going to talk about are multi-step equations. We're looking to solve for something that's trapped inside parentheses. First thing we have to do is get the parentheses by themselves. So on a problem like this, I'm first going to divide 7, negative 7 on both sides. When I set that up, it'd be 2p plus 6 equals, it's a positive answer, 22. And then we're going to get p by itself, subtract the 6. 2p equals 16, and divide both sides by 2, and get p is equal to 8. So the key on that was leaving the parentheses alone, getting them by themselves first, and then solving the problem out. Okay, the next type of problem you're going to look to solve are absolute value problems. Now, why did I put this after the problem from before? Absolute value problems are just like multi-step equations. You get the absolute value part by itself, and then you solve the problem after that. I meant to put this as the problem. There we go. And the question is, how do we solve absolutes? I'm going to show you right now. So what we do is first we subtract 10 from both sides. Absolute value of 3k equals 30. And you notice what I do is I got the absolute part by itself. Once it's by itself, it's going to turn into 2 problem parts. And I put parentheses. You don't have to. It just says that the negative answer to that problem is going to be 30, and the positive answer to the problem is going to be 30. So it's going to go into 2 parts. You can then do what you want with the minus sign. Negative 3k equals 30. 3k equals 30. Divide this side by negative 3, and I get k equals negative 10. Here, divide each side by 3, and I get k equals 10. And with absolute value problems, you always want to, and you'll see why I'm saying this now, you're always going to test your answers out just to make sure. Put negative 10 into the original equation. The absolute value of negative 30 is 30, so that one worked. And the absolute value of 30 is 30. Remember, absolute value signs just strip away multiplication signs. Okay, so the next part of the problem is inequalities. And I've written down a weird inequality. I think I'm missing something. Let me pause. Oh, no, we're good. Inequality right here. So when Mr. Brigham solves inequality problems, he actually doesn't use them as inequalities first. Because there's always these things with the sign, flipping, and switching. I will actually, and you can do whatever way you want. Here's my way of doing it. If you do it the one way, you have to always, if you multiply by a negative number, you're going to flip the sign. What I always do is I turn the problem into an equality to start. I'll show you. 102 equals 3 plus 3. 1 minus 8n. Okay, so I'm going to show you the Mr. Brigham fail-proof method for this, which is, like I said, I throw away the less than sign. I'll come back and deal with that later on. And I can do it on any inequality problem. It actually works out pretty well. I'm just going to solve this equation right now. So I'm going to subtract 3 from both sides. 99 equals 3. 1 minus 8n. Then I'm going to divide both sides by 3. 33 equals 1 minus 8n. Subtract 1 from both sides. And I got 32 equals negative 8n. I'm going to bring this up over here so I have it. Divide each side by negative 8. And I got that n equals negative 4. Now that's not the answer, but on inequalities, if you do it as an equality, you get the point that's the tipping point. Meaning, if I go to here, and I put that number negative 4, the answers are either correct on the left, or they're correct on the right, and I'm not sure which one, but it's always going to be one or the other. All you have to do is test. You pick a number, and if it works, you have the right answer, and if it doesn't, you don't. So I'm going to test the number 0, which is over here. I'm going to mark it on here. You don't have to do all this work to do it. I'll fill 0 into the equation, and I get 102 is less than 8 times 0 is 0. 1 minus 0 is 1. 3 plus 3. Is 102 less than 6? The answer is no, these are not the answers. It's wrong. Okay, so it means that this side has to be the answer. I can test it if I want to. I'll pick a number on that side. Let's pick the number -10. So I get 102 is less than 3 plus 3, parentheses 1 minus 8n. Well, -8 times -10 is -80. -80, 1 minus -80 is -79. And I really don't have to keep going because, oh, that's a negative. Because this number is a really big negative number. It's already going to be a negative answer. It's going to be less than 102, so I know this answer was correct. So you can test one side, and you have the answer. These are where my n's are. So my question is n less than -4 or greater than -4? Look at the number line. N is less than -4 is the correct answer. Okay, so let's try absolute value inequalities. We're going to do the same thing we did on 3 and 2 together. We're just going to do it in 2 parts. So if I had the absolute value of x plus 7 is less than or equal to 3, I'm going to turn this into 2 different problems. X plus 7 is equal to 3, and negative x plus 7 is equal to 3. Why did I get rid of the greater than sign? I'm going to use this to figure out my answers in a little bit. I'm going to divide my graph into regions, and I'm going to solve it from there, but I'm going to do equal signs. I'm going to solve the 2 of these. So I'm going to subtract, this is x plus 7 equals 3. Okay, so we're going to keep going here. This is going to become negative x. I'm going to distribute that minus sign, negative 7x minus 7 equals 3. Now I'm going to solve for x on each side. Subtract 7. X equals -4. And on this side, I'm going to add 7. Negative x equals 10. Multiply both sides by -1. X equals -10. So these are my 2 tipping points for my inequality. I'm not sure which part is the right part of the inequality, but what I'm going to do is I'm going to draw a number line. And I'll fill the numbers I have onto there. I have -10, and I have -4. And this time there's 3 regions on the graph. Well, it's going to be either the middle region or the 2 outside regions, but I can test a number in each, and if the number works, that region is an answer. If the number doesn't work, the region is not an answer. I usually test 0 first, just because it's out there. Put 0 into the graph, and I get the absolute value 7 is less than or equal to 3. Is 7 less than or equal to 3? No, that part's not an answer. It probably means the far end is not an answer as well, which I'm going to test. I'm going to put in -100. 100 plus 7 less than 3. That's the absolute value of -93. Less than or equal to 3. Is 93 less than or equal to 3? The answer is no, it's not here. It's got to be the numbers in this region right here. Let's test one. Let's take -5. -5 plus 7 less than or equal to 3. That becomes 2. 3. Is 2 less than or equal to 3? That's correct. That means the answers are this region right here. That means these are my x's. I shouldn't use these for x, right? Cross those out then. That's right, no. So to write down my answer, it looks like this. X is between -10 and -4. Okay, so what I've given to you, use your calculators a little bit if you need them. I've given you 20 problems. You're going to work on those. They're based on, I give you 20, I give you 5 of each type. They're based on these types right here. You're going to work on them on Tuesday. There will be class help on Wednesday. I'll be available to answer questions during class. And the work will be due on Thursday, in which you'll receive another video for the next lesson. And there we go. Okay, folks, I'll talk to you. Bye-bye.